You might know these gloriously glitchy images, and what they're actually called and the technique that's used to create them is pixel sorting. So let's have a look at how pixel sorting works. What we'll do is we will be working on an image line by line or row by row, but let's stick to line by line for this example. So this is a line of pixels from my image. When doing pixel sorting, we will always look at the pixel's brightness value. So what we'll do is just average out the red, green, and blue in each pixel to give us this brightness here. And next we'd like to select certain regions of our line, as drawn in here. And we're going to select the regions by these rules. We will start with a region when a pixel's brightness is bigger than a given starting threshold, as in this case here, a very bright pixel, so we start selecting pixels. And we will stop as soon as a pixel's brightness is smaller than a stopping threshold that we set. So this one here is very dark, so we'll stop selecting here. And again, we'll go through this line further, and when we reach a pixel which is brighter than our starting threshold, again, we start with a new group, go over these pixels and check, and as soon as a pixel is below our stopping threshold, again, we stop. In this example, I start selecting if my brightness of a pixel is bigger than 0.8, and I stop if the brightness is smaller than 0.2. And while we are within a certain group, and let's look at the first group only here, so while we are within a certain group, we will create 3 lists, one containing each pixel's brightness, one containing each of the group pixels' color, and finally a last list containing the pixel numbers here, so their IDs, so to speak. So in this example, we are going to end up with 3 arrays, one storing the pixel's brightness values, which is a float, one storing the pixel's color values, which is a vector, RGB, and one storing the pixel numbers, an integer. So now that we created those lists, let's have a look at the second half of pixel sorting. So again, our 3 lists, brightness, color, and the pixel number. And what I'd like to do now is sort the brightness values, but with a twist. Instead of just sorting this array and reordering it, we will generate another list that contains the indices of my brightness array, but in a sorted order. That means from the lowest to the highest value here. So you can see the lowest value is the list entry with the index of 6, second is the index 5, and so forth and so forth. And the part where it gets interesting is actually down here, where we actually have some reordering of our list. And why would we want to sort those brightness values in this seemingly complicated way with creating another list and storing an ordered list of array indices? That is because we can use this ordered list of indices here to read out the color values out of our color array here and successively go through the selected points here and just look up the index from the end successively and read that same index in my color array to color my points successively, like so. So instead of reordering my brightness directly and then losing any information about which color was linked to which brightness, I will just generate a list that tells me in which order to go through all of my lists in order to get my colors sorted by their brightness. So again, let's have a look at this. This is my sorted brightness, and we'll start with the brightest color here. That's the last one in this list. So we will look at our color index number 2, which is this bright yellow here. We'll set that to our first point. Then for the second point, we will have a look at the second last entry, which is 0. So we'll look up our color on our position 0, which again is this bright yellow. And for the third entry, third last from the brightness index, it points to an index of 1, which in my color list is this bright orange here, which I'll set here, and so forth and so on. So let's have a shot at implementing this in Houdini. As always, I'm going to drop down a grid here when I'm working on an image, and I want to use this grid just as a cheat. Instead of loading an image in the cops, I will stick to SOPs, so that we don't have to learn any new syntax here. And I'd like to generate a grid that consists out of lines, so we have individual lines that we can work on and sort through. So I'll select polygon as my primitive type, and I will say rows as connectivity. Increase my rows and column count here, so I can see now I have 100 by 100 points. And I will use the attrib from mapSop, wire this in here, to give those points a color. Just under image settings, I'm going to check invert B to actually have the image flip to the right side. And let's load a texture here. And also let's hit D on our viewport and set our background to be dark and uncheck the grid display here and zoom out a bit. Maybe hit space 2 so we switch to an orthogonal view of my grid here. And when I zoom out a bit, I can see what I loaded up is kind of a low-res version of an image of Tokyo at night that I downloaded from Wikimedia. Let's increase our resolution, go to 1000 by 1000, like so. Okay, so now we have this image stored on those individual lines that we created. And what I want to do now is for each line, I want to sort points by their respective brightness. So let's create a primitive wrangle this time, which is a wrangle which will iterate over a given primitive. That means it will run once for each line that we just created. wire this up in here. And the first thing that I want to do is extract all those points that are on a given line. And the function that we're going to use is called primPoints, which will return all the points on a given primitive, in this case on a given line. So let's create a new array, call it npts, and I'll just store the result of my primPoints function in it. And primPoints needs, as always, a geostream, a geo input, and a primitive number in this case. And we just want to have all the points from our currently active prim number here. Let's highlight this. No error so far. Next, let's create two sliders for the starting threshold and the stopping threshold for our group selection. Let's call one startVal, create a float slider, call it start value, and push this button to create the float slider here, and I'll set its value to 0.2. Let's just copy this line, paste it down here, and also create a slider for what we're going to call endVal, for end of selection value. That's the stopping threshold I've been talking about. Let's set its value to 0.006, like so, and also create our three lists. An integer list for the point IDs, let's call it IDs. A float list, that is a float array. For the brightness values of our points, let's call it brights. And a vector array for the colors of our points, let's call it cols. Like this. Also, we need a variable to store if we are currently working within a selection. So if our start value has triggered the selection of a group, or if we are working outside of a selected group. So let's create that and use an integer for it, call it started, and set it to 0 initially because we haven't selected anything yet. Let's create our main loop. So what we want to do is we want to iterate over all points within that line, which we have stored in this npts array here. So let's create a for each. And we will store our currently active point number in a variable called npt, and we will iterate through the array npts. So the first thing we want to do is we want to read in a point's color and convert it to a brightness value. So let's create a vector and call it ncol, and it should store our current element's diffuse color. That's denoted by the shorthand CD, and npt is our currently active point. Let's convert that into a brightness value. So let's create a float, call it brightness. And let's just take the average of our RG and B values stored in our ncol vector, which can be done with the average avg command, which accepts a vector, in our case ncol, and it will average the vector components and store those in a float. So basically what we want to do now are three things. First, we want to check if we are outside of a selection, and if so, we want to check if our brightness is bigger than our threshold value, and then start our selection. So let's do that with the help of an if statement. And we're going to check if, on the one hand, our selection has not started, so that means if started is still equal to 0. And if we haven't started yet, and our brightness value is bigger or equal than our starting value, then we want to do something. And all we want to do is set our started trigger here to 1. So we just change our state. We just enabled the selection of a few points which will follow. So this is one thing that we need to check. Then we need to check if we are started. So if that condition here is met and started equals 1, then we want to build those lists of brightness values, color values, and point numbers. So let's do that. So let's check if started equals 1. And there are two ways how you could write it. On the one hand, you could just put down started equals exactly to 1. However, as Houdini hasn't got any Boolean variables, we can also do that, and Houdini will automatically check if started is 1, and then it will execute this body here, or if started is 0, then it won't execute this body here. So let's stick with this shorter version here. So if we are started, we want to build those lists, which we already created here. So let's fill them with values and push our current point number to the list IDs. Let's also push our current brightness to the list brights. And finally, push our color to the list cols. Okay, so the final thing we need to do is if we started a group selection and if our brightness of our current point is below our threshold. And if it's below our threshold, then we will need to sort our lists, return this array of sorted indices, and use those to write back the colors onto our points. So let's do that in a third statement. So we check if we started. So if started equals 1, and if our current brightness is smaller or equal to our end val. And if this condition is met, we want to end the selection, so let's set our started value to 0 and create this array of sorted indices by creating an integer array. Let's call it sorted, square brackets, and it should be equal to a sorted version of our brights array. And luckily there's this function called argsort, and it just accepts an array name as an argument, and this argsort function will return this sorted list of indices. Now that we have this sorted list of indices, let's write back the values onto our points, and all the point numbers onto which we'll want to write back the colors have been stored in this IDs array here. So let's use that again in a for each loop. And let's call our currently active element ID, and we want to iterate through the array IDs, storing the point numbers. And now for each iteration, the first thing I want to get is the last entry in my sorted array here. So let's call this sort ID for sorted ID. And let's just get our last entry from our sorted array with the pop command. Next, let's look up the color that's been stored at this sorted ID position. So vector col equals cols, and then square brackets, sort ID. And finally set the point attribute storing the color on that point with the point number ID to this value here, using our trusty set point attribute. Again, 0 geostream, color value on the point with the point number ID, and we want to set it to our col value like so. And finally, after we've done this and written back all those values onto our points, let's just make sure those arrays here get emptied again. So let's clear IDs, brights, and cols by using a function called resize, which resizes an array. And let's use this to resize all of our 3 arrays to a length of 0, containing 0 elements. Do this for the IDs, for the brightness values, and for the color values. And that should be it, fingers crossed. And we can see now we have this beautiful pixel sorting effect. Let's save that. And what we can do now, instead of having those lines horizontally, let's head to the grid and select connectivity columns. And we can see now we got those vertical stripes here. What you can do inside the primitive wrangle, if you don't want those colors sorted in a descending order, let's scroll down to the pop command where we get the list entries out of the sorted ID list. We can tell pop to not use the last element but to use the first element by specifying an index, which should always be 0, which is the first element. So now my colors will be sorted in an ascending order. Alright, that is pixel sorting. And I think the point we can make after this tutorial is that sometimes the implementation and the actual writing of the code is not the difficult part. The difficult part most of the times when cooking up setups is coming up with an algorithm and wrapping your head around what kind of elements you need in order for that algorithm to work. As for example here with that trick where we used argsort to generate a list of sorted IDs instead of sorting our arrays directly, which took me a while to wrap my head around when I started using those techniques. So maybe you want to go through this again or experiment with the techniques, see if you can cook up something new, something of your own, which of course we are always happy to see. So until next week, cheers!